Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh dan selamat sejahtera. Untuk video kali ini kita akan belajar mengenai, kita akan masuk lesson 2, topik 4, dan kita akan belajar mengenai stoichiometry. Okay, stoichiometry saya dah pecahkan kepada 3 bahagian. Ini adalah bahagian yang pertama, stoichiometry. Kita nak faham apa itu stoichiometry sahaja untuk kali ini. So, objektif lesson kita adalah to calculate the amount of reactant and product from balance equation. So, how do we use balance equation to calculate the amount of reactant and product? So, listen carefully to what will I explain. Okay, we go to the what is stoichiometry. So to understand the stoichiometry is a quantitative study of reactant and product in a chemical reactant. What is mean by quantitative is quantitative is something that we can calculate. Okay, quantitative is something that we can calculate. Okay, it's a quantitative study of reactant and product in a chemical reaction. And this stoichiometry is used to determine the amount of species using amount of other species in the same balance equation. Okay, it's used to determine the amount of species using the amount of other species in the same balance equation. So, stoichiometric coefficient in a balance equation will show the ratio of amounts in mole of reactant and products. Okay, for example, I have this equation: 2CO react with oxygen, produce 2 carbon monoxide. So what does it means by, how do we use this stoichiometric coefficient? Okay, it shows that 2 mole of carbon monoxide react with 1 mole of oxygen to produce 2 mole of carbon dioxide. So the relationship can be simplified by using symbol triple dash, which means stoichiometrically equivalent to. Okay, that's mean 2 mole of CO stoichiometrically equivalent to 1 mole of O2 and stoichiometry equivalent to 2 mole of CO2, or 2 mole of carbon monoxide will react with 1 mole of oxygen to produce 2 mole of carbon dioxide. That is the stoichiometric relationship between carbon monoxide, oxygen, and carbon dioxide. Okay, let's look at example how to use stoichiometric relationship to determine the amount of other reactant using another reactant in same balance equation. Okay, let's say this example. We have a sample of 50 ml of phosphoric acid is titrated with 25 ml of 0.1 molar sodium hydroxide solution. The reaction is as follows. Okay, H3PO4 plus 2 NaOH produce Na3PO4 plus 3H2O. So, the balance equation is given. So, no need to balance the equation. And then, the question is, calculate molarity of H3PO4. Okay, how to calculate? Okay, we look at the solution. First, we write the equation given. H3PO4 react with 2 NaOH produce Na3PO4 plus 3 H2O. Okay, given in the question is 50 ml phosphoric acid. The volume of phosphoric acid is 50 ml. And then given volume of sodium hydroxide, which is 25 ml. And then concentration of sodium hydroxide is 0.1 molar. So it asks you to calculate the molarity of phosphoric acid. So how to calculate the molarity of phosphoric acid? So to calculate molarity of phosphoric acid, formula molarity is mole of phosphoric acid divided by volume of phosphoric acid solution in liter. Right now the volume is given 50 ml. Just convert it into liter, so it will become 0.05 liter. So how do we calculate the mole of phosphoric acid? Now we can use right now we can use stoichiometric relationship between NaO and between NaOH and H3PO4. Okay, we will use mole of NaOH to calculate mole of H3PO4. Therefore, the first step to answer this question is to calculate mole of sodium hydroxide. So mole of sodium hydroxide, we know the molarity, the formula of molarity is N over V, mole over volume. Okay, volume is in liter. Therefore, to calculate mole, volume, molarity times with volume. Okay, to calculate mole, molarity times with volume. So molarity is 0.1 molar times with volume. Make sure your volume is in liter, so 25 ml. To convert to liter, so it will become 0.025 liter. So your mole is 2.5 exponent negative 3 mole. Okay, and then using stoichiometric relationship, we know that mole ratio, okay, mole ratio, okay, mole ratio of H3PO4 to mole NaOH is equals to 1 over 2. Okay, how do I get this value? This is a stoichiometric coefficient of H3PO4 and NaOH. So when we look at the balance equation, stoichiometric coefficient of H3PO4 is 1, NaOH is 2. So therefore, mole ratio of H3PO4 to NaOH is 1 over 2. 1 is stoichiometric coefficient of H3PO4. 2 is stoichiometric coefficient of NaOH. Therefore, mole of H3PO4 divided by mole of NaOH is equals to 1 over 2 times mole of NaOH. So right now we can calculate mole of H3PO4 is equals to 1 over 2 times mole of NaOH. We calculate earlier is 2.5 exponent negative 3 mole. Therefore, the answer is 1.25 exponent negative 3 mole. Right now, we have calculate mole of H3PO4. So, kita dah dapat mole of H3PO4. So right now kita boleh calculate the molarity of H3PO4. So molarity of H3PO4 is equals to mole 1.25 exponent negative 3 mole divided by volume 0.05 liter. So the answer is 0.025 molar. This is your final answer. Okay, that is how I use stoichiometric relationship to calculate mole of H3PO4 from mole of sodium hydroxide. Okay, now we look at the second example. Okay, given the following equation, CaC2 plus 2H2O produce CaOH2 plus C2H2. Determine the percentage of impurities present in CaC2 if 38 gram sample produce 13 gram of C2H2. Okay, so like example 1, we rewrite the balance equation. Okay, we rewrite the balance equation. CaC2 plus H2O produce CaOH2 plus C2H2. Okay, given in the question is 38 gram of sample. Okay, determine the percentage of impurity present in CaC2 if 38 gram sample. Okay, given the mass of sample is 38 gram. What does it mean by mass of sample? Means that this sample is consists of this 38 gram is consists of mass of CaC2 plus mass of impurities. Means that this 38 gram is not pure. This is not mass of pure CaC2. It is contain impurities. So the 38 gram is a combination of mass of CaC2 and mass of impurities. And then it says that determine the percentage of impurity present in CaC2 if 38 gram sample produce 13 gram of C2H2. So given mass of C2H2 is 13 gram. So how to calculate the mass of impurities? So to calculate mass of impurities, you need to have mass of impurities divided by mass of samples times 100. So mass of sample is given 38 gram. So how do we calculate mass of impurities? So to calculate mass of impurities, we know that mass of sample is 38 gram. So our sample is consists of CaC2 and impurities. So to calculate the mass of impurities, we need to subtract mass of CaC2 from mass of sample. So you will get mass of impurities. Right now, the question doesn't give you the mass of CaC2. So you need to calculate the mass of CaC2. How do you calculate mass of CaC2? You need to know the mole of CaC2. How do you know the mole of CaC2? You will use stoichiometry relationship by using mole of C2H2 to calculate mole of CaC2. So, to solve this question, you need to know the mole of C2H2 first. So, given 13 gram, okay, divided by its molar mass is 24 plus 2, 26 gram per mole. So, you will get mole of C2H2 is 0.5 mole. So right now, using stoichiometric relationship, okay, mole ratio of CaC2 to mole C2H2 is equals to, okay, we look at the balance equation. CaC2 1, C2H2 is 1. So 1 over 1. So mole of CaC2 is equals to 1 over 1 times mole of C2H2. So mole of CaC2 is equals to 1 over 1 times 0.5 mole. So mole of CaC2 is 0.5 mole. Okay, right now we have calculate mole of CaC2. Right now, we want to calculate mass of CaC2. Okay. So, mass of CaC2 is equals to 0.5 mole times its molar mass, 64.1 gram per mole. So you will get 32.05 gram. So this is the mass of pure CaC2. So to calculate, then we can calculate mass of impurities. So mass of impurities is equals to mass of sample minus mass of CaC2 equals to mass of sample is 38 gram minus mass of CaC2 is 32.05 gram. So you will get 5.95 gram. Therefore, percentage of impurities is equals to mass of impurities 5.95 gram divided by mass sample 38 gram times 100 is equals to 15.7%. So that is your final answer. Okay. Now we look at example 3. Okay. A 16.5 ml, okay, 16.5 ml of 0.1327 molar KMnO4 solution is needed to oxidize 20 ml of FeSO4 solution in an acidic medium. What is the concentration of the FeSO4 solution? So the net equation given 5Fe2 plus MnO4 minus 8H plus produce Mn2 plus 5Fe3 plus 4H2O. So how to solve this question? Okay, first we rewrite the balance equation. So the balance equation is 5Fe2 plus MnO4 minus plus 8H plus produce Mn2 plus 5Fe3 plus 4H2O. So right now, given in the question is 16.50 ml of 0.1327 molar KMnO4. So we know that in 1 KMnO4, it contains 1 MnO4. So if we have 16.50 ml of 0.1327 molar KMnO4 means that will also has 16.50 ml and 0.1327 molar MnO4. Okay, and then given to you the volume of FeSO4 solution. So that FeSO4 is in 1 FeSO4, it contains 1 Fe2 plus. Means that if you have 20 ml of FeSO4, means that you also have 20 ml Fe2 plus. So right now, it asks you to calculate the concentration of FeSO4. So to calculate the concentration of FeSO4, you need to know the mole of FeSO4. So how do we calculate mole of FeSO4 from balance equation? So we know that 1 FeSO4 contain 1 Fe2 plus. So we shall calculate mole of FeSO4 if we know mole of Fe2 plus. So how do we calculate mole of Fe2 plus? Okay, we use stoichiometry coefficient by using mole of MnO4. So your first step to calculate this question is to calculate the mole of MnO4 minus solution. So mole of MnO4 is molarity, okay, 0.1327 times its volume. So the volume given is in mil, so you need to convert it into liter, so it will become 0.01650 liter. So the answer is 2.19 exponent negative 3 mole. So by using stoichiometric relationship, mole ratio of mole Fe2 plus divided by mole MnO4 minus is equals to 5 divided by 1. Therefore, mole of Fe2 plus is equals to 5 over 1 times mole of MnO4 minus. Therefore, mole of Fe2 plus is equals to 5 divided by 1 times 2.19 exponent negative 3 mole. So, mole of Fe2 plus is 0.0109 mole. Now we have calculated the mole of Fe2 plus. So we know that 1 mole of FeSO4, it contains 1 mole of Fe2 plus. So if I have 0.0109 mole Fe2 plus, therefore mole of FeSO4 is also 0.0109 mole of FeSO4. So right now, the volume of FeSO4 is given 20 ml. Therefore, the molarity of FeSO4 is equals to mole of FeSO4 0.0109 mole divided by its volume 20 ml. Convert it into liter, 0.02 liter equals to 0.55 molar. So this is your final answer. So I hope that you understand how to use stoichiometric relationship to calculate uh, mole of one reactant if given 1 mole of another reactant. So that's all for this video. Assalamualaikum.